Hello everyone, welcome to Java Data Structure Algorithm interview question series. In each video, we will tackle an important interview question of DSA. I will teach you each and everything in detail, how to build its logic, how to make a pseudocode, how code run in backend, how to make code in a code editor. I will teach you each and everything in detail. So watch till the end. And you can find DSA interview question series playlist link in description box and practice other questions also. They will help you to build logic. And for this video, our question is this. So let's solve it. So our question is rainwater trapping. An array is given which represent height of bars. So I have made this array in a bar chart form and each and every integer in this array represent the height of the bar. Now our first integer is 4. So its height is 4. Next is 0. 0 means no bar is there. So it is empty. Okay. Next is 2. So its height is 2. Next is 5. So its height is 5. Next is 1. So its height is 1. Next is 2. Its height is 2. Next is 3. Its height is 3. And our last bar height is 2 and its height is 2. So the purpose of this question is when it rains, water is trapped between these bars. You can imagine these bars as buildings. You can imagine it like building. Many buildings are there and here no building is there. So you have to calculate, you have to find how much water can be trapped between these buildings. I am saying bars, you can also imagine it like building. So now first we will calculate the value of water trapped between these buildings. So we are finding the value of water. Okay, water, how much water is trapped between the buildings. So we are starting from this bar, 4 bar, because our first bar is 4. So will water be trapped above this bar? Here water will be trapped? No. Why no? Because in left hand side, I am talking about in left hand side, no building is present. So if when it rains, water will come and it will spread it out. Okay, water will come and it will spread it out. So no water will be trapped here. Okay. So our value will be, how much water will be trapped here? 0. Okay. So now next is 0 wala. So when we talk about this building, no water is trapped because there is no building here which can help it to trap water. Okay. When we talk about these bar, they will trap water? Yes. Why? Because in left hand side and in right hand side there are buildings, there are bars which can help them to trap water. If I talk about this jug, okay, this is jug. So how much water will be trapped? This much. Okay. How much water will be trapped? This much. Because in left hand side, when we compare this and this, so when we compare this A and B, which A and B which has less height? This has less height, means A has less height, means it can trap water this much only. Why not this much? Because water will spread it out. That's why. So in this way only water cannot be trapped here because there is no building to support him, so that water can be trapped. When we talk about this building, means here no building is there, here only ground is there. Okay. So how much water can be trapped? Yes, here water can be trapped because in left hand side it has building and in right hand side also it has building to support it, so that water can be trapped. So how much water can be trapped? See, here is no building, so how much water can be trapped? This is one block. Okay, one block, 1, 2, 3 and 4. Okay, this much water can be trapped. I am using pencil for water. Okay, pencil for water. So here water can be trapped. Yes. Okay. Once again I'll tell you. 1 bar, 2 bar, 3 bar, 4 bar. Means 4 bar can be trapped. Why not 5 bar? Because if I tell you that here water can be trapped, but no, water cannot be trapped here. It will spill out, spread it out, because its left hand side, the building is less height compared to its. Okay. So only 1, 2, 3 and 4 unit water is trapped here at 0 bar. Okay. Now we will talk about this 2 bar. Okay. How much water will be trapped here? You have to compare in left hand side also and in right hand side also which building is there. and you have to compare this left hand side and right hand side, and whose height is lesser. Okay, if left hand is lesser, then it will trap that much water. If right hand is lesser, then it will trap that much water. I am saying this because if we tell that water will be trapped as per the height of the taller building, if I tell the water will be trapped as per the height of the taller building, okay, but it cannot be possible because water will spread it out. Okay, so water will be trapped as per the minimum bar. Okay, minimum bar height. So when we talk about 2, so how much water will be trapped? This is the building, so here water cannot be trapped. Water can be trapped where it is empty space. Okay, so here 1 and here 2, so only 2 unit of water can be trapped here. Why not 3? Because this is the taller building, water will spread it out. Just now only I told you that water will be trapped as per the minimum bar height. Okay, this is minimum. Left hand and right hand, you have to compare with left hand building and right hand building, left hand bar or right hand bar. Okay, and whose height is lesser, water will be trapped as per its height. Okay, so now if we talk about 5, so you have to compare. In left hand side, will water will be trapped? Yes, it is trapped here, but not above this building. When we talk about 2, water is trapped above this building, but in this no water will be trapped because there is no building taller than this. No building taller than this. Compare here also. Right hand side also. Is there any building taller than this? No, it is not there. So water will be spread it out. Now, so we are writing here 0. No water can be trapped. Same reason for this also. No water is trapped here. So next is 1 bar height. So now we have to calculate how much water can be trapped. In left hand side, which is the taller building, then this 5, and in right hand side, which is the taller building, this. So we are taking this for example. You can take this also. We have to calculate for each building. Okay, so when we take this building, so we have to calculate its height. So water will be trapped here. Yes, it will be trapped here, means 1 unit. Now, can here also water can be trapped? Yes, because it has more height than this. 3 is more than 1, so water is trapped here also. Not here because water will be spread it out. No, not here. Water will be spread it out. That's why. So 1 and 2 unit of water will be there. We are not calculating. We are not including this bar because there is no empty space. Okay, that's why. So our next is 2. How much water will be trapped above this bar? Only 1 unit. Only 1 unit. Because here is only one building whose height is 3. So water can be trapped only here. Not here because water will be spread it out. Correct? So that's why only 1 unit water will be trapped. Now we will talk about this 3 bar height. So now how much water will be trapped here? No water will be trapped because in its right hand side, in right hand side, the next building height is lesser than this, not more than this. If I take example, if its height was this, okay, if this height was this 4, so can water will be trapped here? Yes, it will be trapped, and our water value will be more. See, so we get much better answer for this. See this. In left hand side, we are comparing this bar in left hand side, which is the taller building, then this. So water will be trapped as per its height. So when we talk about this building, will water will be trapped here? Yes, it will be trapped here, and only 1 unit, but its height is 2, not 4. If it was 4, then water will be trapped here also, here, not here, only here. Okay, but our height is 2, so water will not be trapped here, and here also no water will be trapped. Water will spread it out. So for this 3, answer will be 0, and for this 2 also answer will be 0. So now we will add all these values of water which we have calculated. So 4 plus 2 plus 2 plus 1. What is the answer for this? 9. Correct. So our answer will be 9 when we make its code. But we have to make it pseudocode, then we will make its code. So for finding our final answer, that is how much water will be trapped here, we will need 3 things. First will be our height of bars, our bar height, which is written in this array. Second thing we will need, second is in left hand side we have to find which bar height is more than our current bar height. Means if I take this example 2, so we have to find which bar height in left hand side is more than this bar height. So which is 4. 4 is more than 2. Yes, it is. So second thing will be left hand maximum bar height. And the third thing which we will need is in right hand side which bar height is more than our current bar height. In right hand side maximum bar height we need, and which is 5. When I take this 2 example, in left hand which is more than 2, that is 4, and in right hand side that is 5. Okay. And why we will need it? Because we have to find how much water will be trapped. So we will compare these left and right maximum bar height, and then we will compare this and which have minimum value. Yes, minimum value means I take 2 example. So we are comparing for 5 and 4 which has minimum value. We will take this minimum value answer and we will subtract the height of our current bar. Our current bar is 2. We will subtract this 2 and we will get our final answer, means which is the water trapped. How much water will be trapped between these bars. So see this. Our water will be trapped 2 units. See. Our correct answer, we got it. So in same way, we will calculate all these bar height, compare left and right, which has minimum value. We will take this and we will subtract the current bar height and we will get our final answer, and then we will add this. But we have to find this, so we have to write its code. If one of you don't understand what I am saying, I'll give you one small example. So I'm taking this example 4, 2 and 5. For now, please forget this value, 0th value, forget about this. I'm taking this example. We have to calculate how much water will be trapped between these bars. So this is the left bar, and this is the right maximum bar. I am finding the maximum value of the bar in left hand side more than this 2 value, and in right hand side we are finding the maximum bar value then 2. Okay, so which is 5. So now we have to find how much water will be trapped here. So which has minimum value? Left hand and right hand. Left hand has minimum value, minimum. So we are taking this. Now we are taking this 4, and now we have to subtract the height of our current bar. Our current bar is 2. So now we are subtracting this 2 and we are getting 2. Answer means water will be trapped 2 unit. Here also you can see how much water will be trapped from here. 1 bar and this 2 bar. Only 2 bar. Not here because water will spread it out. That's why. So we are applying 2-pointer approach here, left and right. So we are taking 2 pointers, left and right. So we are taking our left pointer. So for our left pointer, we have to find the bar height in left hand side. In left hand side, whose height will be more than our current bar height. When we talk about this 4 bar, so is there any bar in left hand side whose height is more than 4? No, there is no bar only. So you can write our current bar height only. Okay, if you don't get any bar, then you can write our current bar height for now. Okay, so now we are taking 2. So is there any bar whose height is more than this bar in left hand side? We are talking about left hand side. Is there any bar? Yes, we have. Whose height is 4. So we are writing here 4. Now we take this 2 example. Is there any bar in left hand side whose height is more than this? Yes, it is there, whose height is 4. So for 5, is there any bar in left hand side whose height is more than this? No, there is no bar. So we can write our current bar height only, same as this. Okay, so now for 1, is there any bar in left hand side? Yes, it is there, and its height is 5, which is more than this. Now 2, is there any height which has, is there any bar whose height is more than this? Yes, it is, which is 5. Is there any bar whose height is more than 3? Yes, it is, and in left hand side I am talking about 5. Is there any bar in left hand side? Yes, it is there, and whose height is 5. Now we will take our right pointer in right hand side. First we are talking about left hand side. Now we have to calculate our bar height whose height is more than our bar height, our current bar height in right hand side. So we'll start from here only, not from here. It will be easy for you to understand when we take this example 2. So is there any bar in right hand side whose bar length is more than our current bar? No, it is not there. So you can write our current bar height, that is 2. Now you have to find for 3 bar, 3 height bar. Is there any bar whose height is more than this in right hand side? No, it is not there. So you can write our current bar height. For 2, is there any bar in right hand side, in right hand side whose height is more than this 2? Yes, it is there, and which is 3. Now we will take one example. Is there any bar whose height is more than 1? Yes, it is, and that is 3. So we will write 3. So for 5, is there any bar whose height is more than this 5 in right hand side? No, it is not there. So we will write this 5 only. So now for 2, is there any bar more than this 2? Yes, it is there, and whose height is 5. Now for 0, is there any bar in right hand side whose height is more than this? Yes, it is, that is 5. And for 4, finally we are finding, is there any bar in right hand side whose height is more than this? Yes, it is, and it is 5. We are talking about right hand side, that's why we are writing 5. If for left hand side there is no bar only, that's why we have written its current height. So now I'll tell you what will be the formula for this. We have already done here, but I am writing its formula. We have already done here. So first we are calculating our left hand side maximum bar, then we are calculating right hand side maximum bar. Now we have to compare this left and right. For each bar you have to calculate. For 2 you have to calculate which has minimum value, right or left, left or right, which has minimum value, right has minimum value. Now you can subtract this right minus our current height, and you will get our water value. So what is the value for this? Minimum is 2, right is 2, and our current height is 2, means 0. That's why I have written no water is stored here. So now I'll write our formula here. So we are finding for water trapped, how much water will be trapped and how to find it. Our formula will be math.min. Math.min will find the minimum value. It will compare two values which we will give. Okay, we are giving left and right value. So this math.min will compare these value, and which will be the minimum value, it will take this value and store in its own. Okay, so we have to give its value, two value we have to give so that it can compare. So first will be our left value, left, that is left.I, and next will be right value, right.I. Okay, so it will compare both, and which has minimum value, it will take that value, and then it will subtract our current bar height value, which is our array. This is our array, right? So we are subtracting our array height, array value. That's why I'm writing array.I. So when code editor start running at backend, array of I will be 4. Okay, because our first bar is 4, so its value will be 4. Then it will calculate its water value. Then our array of I will update and its value will be 0. Okay, its value will be 0. Then it will calculate our water height. Then again it will update and its value will be 2. Then its value will be 5, then 1, then 2, then 3, then 4. This array of I is talking about our current bar value, our current bar height value on which we are there. So we got our formula. Now we will write its code. In 1 minute, I'll just tell you how will this formula work in backend. How will our code work in backend, which we will write here. So first our code will compare this left and right value. We will start from here. Code editor will start from our first bar only. Okay, our first bar, which is 4. So code editor will compare in left and right which has minimum value. Okay, so which has minimum value? 4 has minimum value. So means 4 minus our current bar height. Array of I is our current bar height. Our current bar height is 4. So 4 minus 4, which will be 0. So means 0 water is trapped. Water will be spread it out, means 0 water is trapped here. Okay. So now for this 0, it will compare left and right which has minimum value. 4 has minimum value. So it will take 4 and minus our current bar height, means 0. So how much water will be trapped? 4. So see this, how much water will be trapped? 1, 2, 3, 4. Means 4 unit water will be trapped. Now here you have to compare left and right which is minimum. Left is minimum. Okay, so 4 minus our current height. Current height is 2. So 4 minus 2, that is 2. So 2 unit of water is trapped because from here water will be spread out only here. So 2 unit of water will be trapped. For here 5 and 5, which has minimum, both are same, so we take 5. And what is our current height value? 5 minus 5, that is 0, means no water is trapped here. Now next is 1. Okay, so for 1, which has minimum value? Right has minimum value. So 3 minus our current bar height, that is 1. So 3 minus 1, that is 2, means 2 unit of water is trapped here. Now next 5 and 3 compare, which has minimum value? 3. So 3 minus our current bar height, that is 2. So means 1 unit of water will be trapped here. Okay, for now for this 3, which has minimum value? 3. So 3 minus our current bar height, that is 3, means 0 water will be trapped here. And for this also 2, so minimum value is 2. Left and right has minimum. 2 minus our current bar height, that is 2, that is 0 water will be trapped. I have took your time because you can build logic for this question, how code run in backend, how to make code, that's why. Now for code we have to make function, that is public static int trap. Int means we are returning its value from here to the main function. Int height. We are passing this height. Height is our array, each bar height, which we will pass from our main function, which I will tell you later. Or we can name it array also, ARR, because in main function when we will give input, so we can give it as int. Its type will be int because these are the integer, these are the height of our bars, and ARR, and here we will give input, that is 4 0 2 5 1 2 3 and 2. So that's why I am writing here ARR. You can take height also, but I have written ARR, so you do not get confused, that's why I am writing it. So our next thing is we will take a variable, that is n. Its type is n, and it will tell our length of our array dot length, so that our code editor can understood, so that our code editor will tell our pointers from where you have to start and from where you have to traverse. Okay, so that's why we are telling its length. So after telling our code editor that n is equals to array dot length means array's length. So next thing we will write if condition, if n is less than 2, then you should return 0. So after telling our code editor that n is equals to array dot length means array's length, then we are writing if condition, if n is less than 2, then you should return 0 means if only one bar is present in our array, only one bar is present, that then water cannot be trapped here, that's why you should return 0. In our array more than one bar should be present to trap water, that's why we are writing this. Now for left and right pointers, we are making an array, that is int left max equals to new int n, and then for right, int right max equals to new int n. This left max is the array to store maximum height to the left of the each array, means we are storing the maximum height. Now if I talk about right max, the procedure will be same. If I take this example only 2, in right hand side it will compare. 2 will compare with 3. Is 3 maximum than 2? Yes, it is. So 3 will be stored here. Okay. Now 2 will compare. Okay, is 2 maximum than 3? Yes, we are comparing for 2, but we have to update here. We have to update this right max value. So we should also compare with 2 also and 3 also. Is 2 greater than 2? Not greater but equal to. Now 2 will compare with 3. Is 3 greater than 2? No, it is not. So 3 will be remain same. We have done the same thing here. First 2 is comparing with 1. Is 1 greater than 2? No, it is not. So temporary it is stored here. Now 5 will be compared. Okay, so 5 is greater than 1. Yes, it is. So 5 stored. Then 2 will compare with 5. 5 is greater than 2 or smaller? 5 is greater. So 5 will be remain same. Then 0 is greater than 5? No, 5 is greater. So 5 will be there. 4 is greater than 5? No, 5 is greater. So 5 is here. So after this we have to initialize its value. We have made array but we have to initialize it. So for initializing left max, that is 0, we are initializing with array of 0. Okay, and then for loop will be there. So for loop is int I equals to 1. It will start from 1 and it will go till less than n, means array dot length minus 1. Okay, and then I plus plus. So now we have to find the left max, means the maximum bar height in the left hand side. So for that we have to use math.max. Here we are using math.min to find the minimum value, and we are comparing two values and finding the minimum between them. And now for maximum we have to compare. What we are doing here, for 2 we are comparing with this and for this, and when we got the largest value, okay, we are comparing with others also, and when we get the largest value it will be stored here, left dot max. So for that I am writing left max I index math dot max. It will find the maximum value here, left max I minus 1, and first value is our left max, which is I minus 1. I minus 1 where is when we are comparing for this to I minus 1 is its index number is 0, 1, 2, 3, 4, 5, 5. So 5 minus 1, 4 means previous one. We are starting comparison previous one. Okay, starting comparison with previous one, then previous, then previous, then previous, then previous in left hand side. That's why we are writing I minus 1, and our other values we have to compare with two value, our current and with the previous one. So our current is array of I. So we have written this. Now in similar way we will initialize right max value. So right max is n minus 1. N minus 1 means the last index. Okay, Right is the last and left is the first index. So array of n minus 1. Now for loop I equals to n minus 2, I should be greater than or equals to 0, I minus minus. So now why this loop is starting from backwards? I have told you from here. For right, we are taking this value and we have to compare with the right elements. Okay, with the right elements. So we are starting from here. Same as for left one. When we started from here, we have to compare from the left. Means before this bar, no bar is there. And for right, before this bar, no bar is there. And now why we have written this n minus 2? Because the last bar means this bar. We are starting from backwards. Okay, we are starting from backwards and it will go till our first index. So our last bar knows its own height. Means last bar knows its height. That's why. For comparison, we need another bar which should be present here, but there is no bar. That's why we are starting from this. So it can compare with some other bars and it can return its value. That's why we are starting from here. This two don't have any bar in right hand side to compare. That's why we are starting from here 3. Okay, n minus 2. That's why we have written. And it should go till the first index. Start from the last and it should go till the first index. And I minus minus because this loop is iterating from backwards. Now we have to find our right max value. Right max value is the maximum bar height in the right hand side. Okay, so for right hand side we have to compare between two values. First is our current bar. Okay, if we take this 3, our current is 3 means our current is 3 and it have to compare from right hand side all the bars. So only one bar is there, so it should compare with 2. Is 2 greater than 3? No, it is not. That's why it will return 3 only. So if I take example this one, so it have to find the maximum bar height in right hand side. So for 1 it will compare with 2. Is 2 greater than 1? Yes, it is. Then 1 will compare with 3. Is 3 greater than 3? Yes, it is, but it should be greater than 2 also, because we have to find the maximum height. So yes, 3 is greater. Then 3 will be stored in this right max. Then 2 will compare with 1. Is 2 greater than 1? Yes, it is. It should be greater than this also, because we have to find the maximum bar height. Is 2 greater than 3? No. So 3 will remain the same. So what we are doing here? We are comparing between two values. First is our current bar height, and second is the right hand side bar height. So we are writing here this math.max will compare between two values. First is right max is the right hand side all the bars. If we are taking this one example, then I plus 1 will be this 2 means next bar. Then it will compare with next bar, then it will compare with next bar. That's why we have written here I plus 1. We have written only one value, that is right dot max. We have to write two values. The second will be our current value. We are comparing with current and the right hand side bars. So our current will be array of I. So now we have find left values also and right values also. Now we have to find our water trapped, means by this formula. So now we will write this in code. So for water trap I am writing it here so that you can see this also and this also. That's why. So for water trap we are writing int trapped water equals to 0. Initially it is 0 because when code editor will run, it will be 0 at initial point. Then it will update itself. Then we have to calculate the trapped water for each bar. For each bar we have to calculate. So for that we are writing here for loop int I equals to 0. It will run from here start till the end. Till end. I plus plus. Then we have to find our trapped water with this with this formula. Our formula is math.min. Math.min will compare between this left max and right max. Compare with this, and whose have the minimum value, which left or right has the minimum value, it will take that value and subtract our current bar height from that. Okay, so we will get our water trapped answer. So for that we are writing trapped water equals to trapped water plus, we are writing this trapped water again so that it can update its value for each iteration. Math dot min. Now left max, we have to compare between two values. First is the left value and then is the right value. Left and then right max. It will compare between both, and whose have the minimum value, it will take that value and store in this math.min, and then we will subtract our current bar height from it. Now we have written our complete code, and from here we will return trapped water because we have used n type of, that's why we are returning it from here to our main function. And if you don't know what is the difference between int, boolean type or void type, so you can watch my video of methods and functions in Hindi. I have uploaded on my channel. You can find its link in description box. If you want me to make it in English, I will make it. You can comment below. So now we have written our whole code. We have to only write our main function so that we can call this function, trap function, from our main function. So for writing this, we will write public static void main string args. Okay, so now we have to give it our input. Our input is this 4025122, because we have to find its rainwater trapped value. That's why we are writing here array 4025122. Now we are calling it, okay, now we will call it, I'm writing it here, system dot out dot print ln. Here we are calling this trap and we are giving it input, our array input, that is this. So when we are calling it from this main function, we are calling this function from main function, a call will be gone to this function, and this array input we have given, this array input will be stored in this array, and then this whole code will run in backend and it will find our rainwater trap. First it will find left, then right, then compare, then it will subtract these values from this, and it will give our final answer. So let me tell you what will be its time complexity. When we talk about this left max, we iterate through the array once from left to right. Okay, so from once left to right, and during this iteration we are comparing the height of each bar with the maximum height. Okay, so since we visit each element of the array exactly once, so then this step takes big O of n time, where n is the number of element in the array. And now if we talk about right max, so in right max also we are iterating through the array once from right to left. Here we are iterating left to right, here we are iterating right to left, but once only. So that's why it will also take big O of n time. And when we talk about this trapped water, we iterate through the array once again to calculate the trapped water for each bar. Okay, for each bar we are calculating. So then it will also take big O of n time. So total big O of n, big O of n, and big O of n. So it will take big O of n time. and n is the number of element in the input array. Okay, our input array is 4025122. So now we will start making our code in our code editor. I have made a function whose name is trap. Its type is int because we are returning it from here. Input pass, that is array arr, its type is int, and now we have to give here its input. So our input is 4025122. Now we have to call this function, so we are calling it. So for calling this trap, we have written its code system.out.println total trapped water trap array, and here we have given our input arr, that is this. So now in our function we are making a code. For this code we have to first define our length, array length, that is n array.length, and now we are writing here a condition which is if n is less than 2, means you have to return 0. This line means in our array bar should be more than 1, not less than 1. That's why I have written n should be less than 2. If n is less than 2, you should return 0. We need more than 1 bars, then only water can be trapped. If it is less than 2, water cannot be trapped. Okay, so now in the next line we are writing here left max, means we are making an array for left max to store maximum height to the left of each bar. Now we are making right max to store maximum height to the right of each bar. Now we have to initialize our left max and right max. For left max I am making here, for left max we have given value array of 0, means at 0th index. Okay, because we have to start our left from 0th index. Now we are writing our for loop. This for loop will run from first till the array.length -1. That's why less than n and I plus plus. So it should update its value and move to another index one by one. Okay, so now we are making this variable left max of I is our index, and we have to compare. For left max what we are doing, we have to compare our current bar with the left hand side present bars, and we have to find our maximum bar height. That's why we are comparing our current bar height and from the left hand side bars height, and we are comparing which is the maximum you should return. If our current bar is maximum, you should return our current bar height, and if the left hand side bars are maximum height, then you should return it. That's why we are return math.max. And now for next we are initializing right max array. For right max array, it's array of n-1, means last index. For right max, loop will start from the last index. Okay, but we are writing here n-2. See here, we are starting its n-2 because the last index knows its own height. That's why we are starting it from n-2. Okay, and it should go till our first index backwards. Okay, and this loop is running, iterating from backwards. That's why we are writing here I minus minus. Now for right max, similar as left max, we have to compare our current bar height and the right hand side all the bars present. We have to compare from them, and whose height is maximum, it should be stored here and then here. Okay, if our current bar height is maximum, then it should be this only, and if right hand side bars are maximum, then it should store value here. Okay, now for calculate trapped water for each bar, we have calculated right hand and left hand. For trapped water I have defined here, that is 0, and for the formula we are writing here. For formula, initially a loop will run, that is for loop. It will start from 0 till the array dot length -1. Then we are writing here formula. Math dot min means it have to compare two values. First is right max and then is left max. Compare both the values whose value is the minimum. It should take that minimum value, and then our current bar height value should be subtracted from that value. Okay. After that, we will get our trapped water, and then we will return our trapped water from here. Okay, and we are returning this trapped water to our main function because we are calling it from here. Now it will return from here. Okay, I hope you got this. Now we will run our code and we will get our correct answer. And I have also uploaded Java data structure algorithm complete course in Hindi. You can watch all the important videos, all the advanced topic videos with interview questions. So you can get the links in description box. So we have got our correct answer, that is 9. So our correct answer is 9. So if you like this video, don't forget to subscribe to my channel. And if you like this video, don't forget to subscribe to my channel so you never miss an episode of DSA interview question series. And like and share with your friends and family. Comment. Thank you so much for watching. See you in the next video.